All right, what's going on, guys? Your everyday math tutor here, and in this problem, we have a system of equations, and we need to use the process or the method of elimination to solve for the solution. Excuse me. So, first thing I'm going to ask myself, do they have the, or do the like terms have the same coefficient? So, or in other words, do the two variables, the x or the y, do they have the same coefficient? No, they not. No, they do not. Okay, well, then I ask myself, do they have different signs? Well, they don't. They both are positive, and here we don't have a sign. That means it's positive, of course. So we're going to need to change one of these two variables depending on which one we want to eliminate. So let's try to eliminate the y's first. It doesn't matter which one you start with, but let's start with y. So, of course, we just established that they don't have the same coefficient. So we're going to need to look for what is called the least common multiple. And then we ask ourselves, how can we get to that least common multiple? So here's how we do it. We write their coefficients for y, because that's the first one we're going to try to eliminate, the first variable. So the coefficients are 4 and 2. And we start writing down their multiples, 4, 8, 12, 16, and then 2, 4, 6, 8. Well, right off the bat here, I can see that the least common multiple is 4. So now I ask myself from the very first equation, because this is the first equation here, or rather this over here is the first equation, do I need to change the 4 to get the 4? No, there's nothing I can multiply by. Oh, I can multiply by 1, but that wouldn't change anything. We don't need to multiply by anything in the first equation to get to 4. So this first equation will be left alone. Nothing will be multiplied to the first equation. But I can see from the second equation, the coefficient of 2 needs to get to 4. And well, how do we do that? Well, we multiply by 2. But before we do that, we need to ask ourselves, do the y variables, the ones that we're eliminating, have different signs? They do not. So because we are multiplying the second equation, we're going to need to multiply by -2 in order to get opposite signs. So we will multiply by -2, and that's it. So the first equation, we don't have to do anything. So we just rewrite it. 3x plus 4y is equal to 1. And now the second equation, we start multiplying. -2 times 5x is -10x. -2 times 2y is -4y. And -2 times -3 is +6. And now we can use the process of elimination, or the method of elimination, to eliminate my y variables, because now they have the same coefficient and they have different signs. So if I add them, they're going to eliminate, hence the process or method of elimination. So let's add every term here. So 3x minus 10x is -7x. 4y minus 4y cancels out. It becomes 0. And 1 plus 6 is 7. And we divide to isolate the variable. Divide by -7. And we're going to get x is equal to -1. Okay, so we've gotten a value for x. Now all we need to do is find a value for y. How do we do that? Well, we can substitute this x into any one of the two equations given. Let's put it in the first equation. Let's substitute x is equal to -1 into the first equation. So we will have, let me just rewrite, 3x plus 4y is equal to 1. And now that we solved for x, we have 3 times -1 plus 4y is equal to 1. After multiplying -3, or 3 and -1, we get -3 plus 4y is equal to 1. Now I need to isolate my y, so I'm going to have to add a 3 here. That becomes 4y is equal to 4, and then divide by 4, and we're gonna get y is equal to 1. So there we go. Now we have a value for x. Whoops, sorry. We have a value for x, and we have a value for y, and we just write it down in the ordered pair form. X comma y. We solve for x, that being -1, comma, y is 1. And this is our solution.